So in short, limit does not have to be defined. That's what I'm trying to say, half and half. When you say define, it doesn't mean it have to be defined exactly a specific number, a constant. Define in this case, it could be infinity. Going to infinity technically is some achievement already. It's still better than D and E. Okay. Analyze tangent of x. Tangent of x. Anyone can, maybe give you maybe 5 seconds. Try draw. What does tangent of x looks like? Try it. See anything from I don't know if you're gonna break the your instructor, the trick instructor heart or not. You know, don't break the heart. What is the trick? What is the tangent look like? Sine, cosine is simple, right? The wave. I have the phone number of the trick instructor. Okay, from your last semester. When I look up, hey, what happened? They cannot. What happened? They cannot draw the tangent. Right? What does it look like? They're gonna have a bunch of vertical symptoms. Tangent of which number is undefined?
Pi over 2.
Pi over 2. And therefore you keep going with the pattern. And over here, negative pi over 2. Okay. So you have something like that. Negative pi over 2. This would be pi. This would be 3 pi over 2. This is 0. Negative pi. Okay, sound about right. So, look at those dashed lines. What's the name of those lines?
What was the question?
These dashed lines right here. Asymptote, but more vertical asymptote. They are vertical asymptotes. Vertical asymptote. Vertical. Those are vertical asymptotes. Okay. All right. Then, if you want to analyze this, okay, I want to learn the behavior of this function around an asymptote. Let's pick the best one, the easiest one to analyze right here, pi over 2. Right? Now I know the vertical asymptote is pi over 2. Pi over 2. Then if I ask the question, what's the limit when x approach pi over 2 on the left? Positive infinity, right there, right? On the left. So going to pi over 2 from the left, coming to pi over 2 from the left, your function should have. Right? In the other direction, going to pi over 2. So I think you can fill in this question. Limit of tangent in this case, right? When x approach pi over 2 from the left, pi over 2 from the right, and how about from both sides? I let you fill in the blank, right? Coming to the left, coming to the right, very simple. From both sides. So that when you have an answer, a limit that equal an infinity, you don't say that equal technically. When you have a number, a certain number, 5 limit equal 5, limit equal 6, limit equal 0, then yeah, you can say it's equal. When your answer is infinity, you say the limit approach infinity. Okay, mathematically, you don't say limit equal infinity. Infinity never equal to anything, right? A huge number, a very huge or very small number, you never equal to anything. You don't know how much it is. How can you know, say it equals something? So when you say that it is positive infinity, usually you say it's approach infinity. It's approach negative infinity. It does not exist. Okay, mathematically, that's how you say it. All right, that's tension, very standard. How about another example? Another example. This time I'll be creative, right? Okay, something like this. -2, maybe 1. Okay. Can you analyze the limit at -2 and 1? That's mean. When you say the analyze limit at some number, that means you are looking on the left and on the right, right? Okay, try that. And when you try this, don't worry about the scale. Just try to make a quick, smooth curve. The important is just make sure the -2 on there, and then left side and right side go up. This one, left go down, right go up. You can go anywhere here. So when you do that, then practice another one. How about 1 left, 1 right, 1 from both sides, right? Okay. Easy, right? Simple, right? Okay. So that is for left. Okay. For -2, what do you have? Infinity, positive infinity, or infinity, infinity. Therefore, left, right. You go to approach infinity. Okay. All right, so -1, positive 1, you can try that. So that's the limit. Limit, that goes to infinity. Now, how about limit at infinity? Limit at infinity. That means like this. Limit at infinity means the infinity is when you have x approach infinity. This is what we're going to analyze. This is new. This is kind of new today. So far, every problem that we have so far, x approach a, remember? Some number. So we use that number, we plug in. And if we plug in this undefined, we play around. Okay. We factor, we do all kind of thing until we can plug in. But this time, x approach infinity. We kind of can plug in infinity. We can plug in infinity, but we have to plug in carefully. Okay. Also, all the technique to do this. Okay. That's why we have the whole section down there, just to serve the purpose of finding the limit at infinity. Okay. Before we moving on, recall from the pre-count the idea of horizontal symptom. We just mentioned the vertical symptom. Horizontal symptom. Horizontal symptoms. Let's say I have I have 1/x². I have this. I have that. That is my function. How do I draw that? What?
It's a hyperbola inside.
Yeah. Hyperbola. This is that. We just know that. That plus 3 function transformation, what do? Shift it up 3 units. 1, 2, 3. And when we shift it up 3 units like that, we have, or we create a horizontal asymptote. Horizontal, right, asymptote. That is a horizontal asymptote, y equals 3, right there. Okay. Then, what would be the question in here? The question in here is the limit when x approach positive infinity, right? Limit when x approach positive infinity, x approach negative infinity. That means x is right here. This is your x-axis. When x approach positive infinity, that means x getting larger and larger and larger and larger, larger and larger. Over here, somewhere down here, right? X approach positive infinity. Where's your function going? When x, maybe, let's pick right here, or here. Where's your function at that moment?
It's going closer to 3.
Yeah, right there. Right. The more you get over here, the x get over here, your function keep going. They go parallel, right? But no matter where this one going, it's on way parallel or approaching closer and closer and closer to this horizontal asymptote. It's called asymptote for a reason. Asymptote is a line. Asymptote is a line that you come closer and closer, but you never cross, you never touch. You go to infinity, you go forever parallel to each other. No matter how many miles I draw this line, those two lines far away, they always stay like that. Okay, they never talk, they don't even touch. They're only like this. Therefore, when x approaches infinity, this line approaching to this dashed line, right? This solid line approaching this dashed line, and dashed line is 3. So therefore, limit when x approach positive infinity of this function is 3. Going the other direction, I also have 3, because right here on this tail, that tail is with that, this tail is like this. Okay. Any question? One. Okay. If you are in 113, okay, some of you 113 or 112b, this is behavior and behavior, right? And behavior. Recall that? And behavior. And these were behavior near vertical asymptotes, right? From 113. Okay. So and behavior. But instead of saying and behavior, remember f of x, back a day. Not really back a day, just last semester, right? Just you write, you find, you fill in this, right? Right? Remember that? Positive infinity, positive negative infinity, you go to 3, right? Instead of writing that, now we have calculus way of writing this. Okay. Now, evaluating this, a little bit more complicated, using both algebra and graph. Okay, of course, I will give you the graph of this, but let's do algebra first. So algebra. That means just plug in analyzing that as much as possible. Okay. X squared minus 1 plus 1. What do I do? What do we do? Difference of square, right? The numerator. X minus 1, x plus 1. Clearly, there you go, difference of square. And down here, x plus 1. Cancel. Okay. When I say that, okay, you kind of like able to plug in infinity. When you have x approach a, you can plug in a. When x approach infinity, you kind of plug in infinity when it's simply enough. Plug in infinity is more sensitive than plug in a number, because you need to analyze it. Now it's simple enough, just x minus 1. After I simplify, it ends up to be x minus 1. Okay, so now I'm good to go. I'm good to plug in. So I'm going to plug in infinity minus 1. In this section, whenever you mention infinity, don't just say it as a word. Try to imagine that. Try to get a grasp of infinity. Infinity means something extremely huge. Some number that's very large. You have a billion. Oh yeah. Elon Musk gave me $1. Does he go broke? No, right? Right. He keeps being billionaire, right? Right. No matter how much you have, subtract $1, right? Even $1 billion, it doesn't matter, right? It's still infinity, right? So you have something huge, you minus 1, it doesn't affect, right? If a negative infinity, okay, so in other words, infinities or negative infinity over here, you add, you minus, or you, whatever you do, but you multiply is different. Infinity, when you multiply, we'll come to that. But for now, subtract or adding some certain number to infinity doesn't change the value of that. Okay, so algebra. Now how about graph? I give you the graph. -1, -1. Oh, yeah. One right here. No, -1 on the left side, my bad. -1 here. There. Similar like that. Thumbnail just like that. Okay. So limit when x approach infinity. Look at this graph. Look at this graph. X approach infinity. X approach infinity. X go to infinity. That's mean on the right hand side. X go to the right hand side. Your function shoot up to infinity, right? Just clearly, you can visualize it. Okay. Moving on. Okay, I give you a graph. Try to identify the vertical symptom and horizontal symptom. Okay. Limit in infinity and a graph. This should be a good problem for you to practice. Okay, practice. Let me generate something for you, good for you to practice. Let me see. Okay. Let's do an activity. Grab a partner. Get out a piece of paper. Okay, now you can make a group of 3, maximum 3. Okay. Grab a piece of paper. Fill in your names of your groups. This also your attendance too. Okay. Do this problem. Why are you doing that? I'm gonna make the problems.
was got so bad one time when I went to after not year though in my high school. I scored 100 too. It's better than Mark.
Okay, so that will be your problem. Okay, you have a group of 3, 4. Okay, okay. Identify on the horizontal symptom, on the vertical symptoms. If you have vertical symptom, limit on the left of that vertical, right? Limit on the right of that vertical symptom, left, right, and then limit in infinity. Okay, let's try that. Try that. Okay. Make sure file group, huh? Make sure do it in group because I'm going to collect your papers with your names on that. That will be your attendance today. So don't do solo. Find some friend. Grab a partner. Turn the chair around. Okay. And this activity, I go around. If you have any question, let me know.
The limits near the vertical? Yeah. Find the limits near the vertical
So which one vertical symptom?
2 and negative 3.
Correct. Any question? Which one is vertical symptoms for this group? Which one is vertical symptoms?
-3.
How about horizontal symptom? Correct. Bless you.
-3, 2, horizontal asymptote. Looks like the horizontal is.
What are the vertical symptoms? Okay. What would be the limit on the left of 2?
Negative infinity.
On the right of -3. On the right of
Positive infinity.
positive infinity. Okay.
non-intersecting the horizontal is non-intersecting the one that's negative.
Yeah. So then you have to do
What are the vertical symptoms? I mean horizontal symptoms. Correct. What would be the limit when x approach negative infinity? X approach negative infinity. Correct. What would be the limit on the left of 2?
Negative infinity.
Correct. Good.
that way. So negative 8 is going
Okay, let's see.
Right to the vertical, near the vertical.
Oh,
Because
-3 is a vertical symptom, correct? But on the right, if you zoom in closing, on the right, you look at on your function on the right. This is your function. You look at this curve. So on the right of 3, which is right here, right?
Yeah.
Where does it go?
Up.
Up to
Infinity.
infinity.
Okay.
So not 3 point something. Okay.
From, let's say, the left would be negative. Goes to infinity. Would be negative. As that's equation.
Wait, was that the one you said that you got?
Because the x is
I remember you said you got it sometime.
that's all the way. The limits are horizontal systems. Or, sorry, the
Should we have everything?
You should have left it a little while.
as it approaches from the right towards the other side.
I'll do the other part. I want to make the other part.
Okay.
Therefore, they don't matter. It doesn't make sense.
All right. Everyone. Okay. Let's we still have a couple of minutes. Okay. Let's call it group. Okay. So this will be group number 1. Right. Start number. Remember your number, huh? Group number 2. Number 3. 4. Maybe down there. I forgot that. 5. You too, right? 6. 7. Okay, 7, 8. And who's you with? 9. Okay. Moving up, yes. 10. 15. Okay. Number 9. Remember your group, right? Number 9. Number 9. Where's number 9? Okay, yeah. Number 9. What's the symptom? Will be correct. Okay, so looking at negative 3 first. Number 10. X approach negative 3 from the left. Number 10. Where's number 10?
I'm going to be positive infinity for both. So that's in the right.
Left and right. Wonderful. Positive infinity. Because right here, where you're looking at, there you go. Right. Okay. Actually, I'm not going to start right now. I'm going to let you read it. How about 2? On the left and then on the right of 2. Number 4. Group number 4. On the left is negative. On the right, positive. Okay. How many vertical asymptotes, horizontal asymptotes are there, and what are they? Number, what was the last one? 15. Vertical, horizontal asymptote. Negative 2 and 1. But if you write that precisely, what would be that be? X equal or Y equal? Y equal. Keep that. Okay. Now limit when X approach negative infinity. Number 1. First group. Limit of f of x when x approach negative infinity.
Oh, it's 1.
It is 1, correct, right here. All right. Now 7. Last one. 7. Where's 7? Okay. 7 and 8, right? Around there. 7. Okay. What do you think? Yeah, discuss. Huh? Negative 2, correct? When x approach positive infinity, negative 2. Okay. So, very good, very good. I think you understand the concept of infinity. You was given a graph, right? You generate this information. Everyone. You have the graph, you have this. Now, if I ask you to backward, I give you this. I want you to draw the graph. Okay, so every group, try that. Next page. Now those are your information. You also have zeros. 0, actually, number 7 I can't already. Number 9 already. Number 3, group number 3. 0, x equals 0 and x equals 2. Those two 0. In this context, what does it mean? Who just say that? Who just say that first? Huh? They are x-intercept. So use that. So whatever you draw, when you draw this one, you're gonna cross the x-axis somewhere at 0 and 2. And that is the only 2 places you're gonna cross. Yeah.
How the limits is this negative 1.
Oh, there's negative. Okay, so my bad. Typo. Is one negative. Thank you, let me know. So cross out one negative. Okay. Just negative. Just one negative. Okay. Okay. Plot that. Those are the given information. Okay. Everybody have the notes, right? I don't think I need the. Okay.
Yeah, that's because three, that's there's 2x.
Group number 10. Where's number 10? Group number 10? Where's group number 10? Did I call number 10 already? Yeah, I did? Okay, number 10. Okay, 11. 11. Where's 11? So 10 over there. Where's 11? Huh? 11? Okay. 11. By looking at those information, how many vertical symptoms are there? 2. Okay, draw that. Here. Go ahead. 2 vertical symptoms. Go ahead. Okay. Next group. 11 already. Okay, now 12. After that, okay, so 12 you can go up right away. The horizontal symptoms. Draw the horizontal symptoms. 12. Feel free. Take it down. Don't be shy. So 11 is going to be vertical. Okay, horizontal asymptotes.
Kind of is this one. With the one. With the one approaching from the positive side. From the right side. So the thing is that since the thing is right here, there's no way to cross it like that. There's no way to like that.
-2, correct? Okay, give a number, right? Okay, correct. Yep, correct. Okay, vertical asymptotes. 3. Okay, go ahead. Vertical, right? There you go. Yeah, you can go. How about the other one? Good. Okay, good. Number 6. Can you label just the zeros? Label the zero. That's easy. Label the zeros. Anywhere, use any marker. Label the zero. The x-intercept. In this case is 0 and 2, right? 0 and 2. Make it, yeah, how you label that? Okay, good. Actually make it closer to 3. That's 1, right? Because if you try at least, like proportional. So closer to 3 because that 3 is vertical asymptote. There. Okay. So 0 and 3. Okay. Anyone? Okay, now let you volunteer. The first section. How do you graph on the first section? Go ahead. Or even better, if you want to finish the whole thing, go ahead.
I was cursing out my cousin the other day. I was with my niece, and he said that it's funny.
Beautiful. Okay, correct. Between 2 vertical asymptotes. Anyone? How about 15? Go back. 14. The middle section. It's tricky. A little bit tricky. Make sure because in the middle you have 2 zeros over there. So go ahead. There you go. Good. Okay. So I'm going to use the, let me use the black one to make it. Right. This is vertical asymptote, horizontal asymptote. Okay, finish off. Number 3, group number 3, last one. Down there. Finish off the last section over here. Yeah, any marker there. Okay, any marker. Pick one. Is it on the right of 3? Hold on. Let me put it back. On the right of 3. Actually, right here. On the right of 3.
Oh, it's negative.
Negative. So it's going to go down. There. So down there. Yep, correct. Put it down and curve that. Correct. There you go. Beautiful. That's how you graph from given information, right? Okay. So, yes, any question?
When drawing in this example, 0 and 2, so long as it's continuous, does it matter how it's drawn?
Does it matter how strong?
So for example, for that part of the graph between the two x-intercepts,
Oh yeah, doesn't matter. But okay,
as long as it's continuous.
okay. Good question. Everybody. I want to show you this. So you have two x-intercept. So when you want to connect these two, it doesn't matter how you connect them as long as you maintain only two x-intercept. For example, that is one option, right? This is also another option. So technically you can do like that. Up, back up. But the moment you cross is another term like this. Is it true or wrong?
No.
When you do this, you generate another x-intercept there. Right? So no matter how you draw, or you can do this. It doesn't matter. Right? It's still correct because I only have two x-intercept. Okay.
Wait, can you actually do that? Because it doesn't have to like pass the verse behind us.
Yeah, doesn't have to be. Yeah, can you hear? Too much, right? There. All right. Okay. I will see you tomorrow. Turn in the paper, whatever you have so far, with your names. That will be your attendance.
I thought you were gonna cross all over.